Here we have part 1, chapter 26, of what is the fluid electrolyte and pH, but also acid-base balance of the body. One of my very favorite parts of anatomy and physiology, because it is sort of the hidden part where we look at what's actually health and pathology on a sort of more intrinsic situation. And we have a condition called steady state homeostasis. It was something that was brought to our attention by a 19th century scientist, Claude Bernard, who had many famous professors and who in many ways shined far above them and made 20th century physiology possible. And he was the one who considered the idea of the internal milieu of the body, or the internal, how shall I say, environment of the body is in a state of steady state. We have balance, which is to say we need to have a certain amount of oxygen or nutrients of some kind or another, glucose, etc., at any given time in the blood. And so we're accomplishing that by synchronicity. So we're breathing in, we're breathing out, and we're maintaining a steady state of oxygen. And we're eating and also eliminating. We're sleeping and waking. There's many synchronicities in the body, including negative feedback homeostasis, in which we are creating biosynthetic pathways, and we appropriate substrates and move things along enzymatic pathways in order to build product and then ultimately move it out. And of course we have to have the passageways clean and clear, so we have uninhibited flow, so that the substrates arrive at our 40 to 50 trillion cells in the endothelial matrix, and then we also have a healthy flow-through matrix in which waste products can be picked up by the bloodstream and removed. Right? So there's no stasis. We have uninhibited flow. Okay, so in this sense, chemical equilibrium is balanced life. Is death, actually. Chemical, pardon me, steady state homeostasis in a balanced, synchronous, and uninhibitedly flowing way is the ideal of life. Chemical equilibrium. So equilibrium itself is death. We learned about equilibrium toward the beginning of Biology 20A when we discovered that a system that it's at rest and that has come to a state of equilibrium and is no longer having any diffusion gradients to speak of, this situation is basically a non-living system. Okay, and in a living system, we have lots of diffusion gradients, and they're all under a certain level of balance and synchronicity in terms of conformity, and there is, when we need to, we can move fluidly and easily and without hesitation. Okay, so I have friends who are my age, and when they bend over to pick something up, they sort of grunt or groan a little bit. So they're not quite the same as a child. If you look at a 4 or 5-year-old pick something up from the ground that they're curious about, they're not grunting and groaning to pick it up, right? And they're not hesitating to play. Okay, so these are things that are characteristic of, how shall I say, human life that is rich in these qualities of homeostasis. So we move on then to this next page over here, where we're at 991, right there. And we have a nice table here, a little graphic display of where's the water in the body, the major fluid compartments. And so they're telling us right here at the very top of this page, and this is an important idea, that total body water represents about 60% of the body. Okay, so in someone who is relatively lean, more toward the lean side, it's maybe just a touch over 60%. Someone who's carrying a little extra weight, it turns out that adipose tissue is less of a percentage of water weight, whereas muscle and other tissues are having a much higher percentage of water weight. Okay, so 60% of the body is water, And then in terms of the percentage within the body, the greatest amount right here is going to be intracellular. So most of that water, the 6 of the 40 liters, 25 of which is inside the cell. So that would be 5/8 of the 5/8 is more than half of the water is inside the cells, and then the rest of it is outside. 3/8 of the water is outside of the cell, and this would be then identified as the matrix. Okay, so one could say the endothelial matrix, the interstitial fluid regions of the body that are outside of cells. So it's within tissues of organs and outside of organs where there's areas of perfusion. And then we have that portion outside the cell in which the liquid tissue moves, and that would be the blood. Okay, so we have maybe 5 or 6 pints of blood if you're of the female persuasion, and then 6 or 7 pints for the male, something like this. Okay, so, and I'm noting here, this is the internal milieu of Claude Bernard, and this is some of the primary areas here, all of these interfaces, whether it's this interface between the matrix and the cell, or the interface here between the matrix or the interstitial fluid and the blood. This is where homeostasis is, so shall we say, regulated. Okay, and so here we have, I call this meals on wheels. This is getting everything around, whether it's hormones or whether it's essential nutrients. All the substrates of life are moving through the blood, and with the blood and also the waste products that are being removed from the cellular tissues are also being removed here. So it's important to have this in mind. Another detail that's of great importance is that every single cell of the body has a pump. It's pumping sodium out and potassium in. This is not just a feature of the nerves and the muscles. They do utilize this in order to have a resting potential on the surface of their cells that can be expressed as an action potential. But actually, it turns out every cell is working this way. So whenever we find fluid that is rich in potassium, and we do find this in certain places, particularly in that portion of the body that operates the hearing system as well as the static and dynamic equilibrium or balancing system of the body, there are large areas of fluid that are purely of the potassium-rich persuasion. The exchange, of course, is then with sodium. So over here we have sodium-rich fluids, whether it's the interstitial fluid here or the blood. The primary electrolyte is going to be sodium. Sodium out here, potassium here. That's the unique feature here in terms of the overall situation.